Hello everyone and welcome back. In this episode, we are uh, calculating the center of a shape. Why do we need to do that? Because later on we're gonna have a rotational impulse and, well, rotating objects, of course. And we need to rotate our vertices around the centroid of a shape. For circle and for rectangle, it's pretty easy to calculate, but for an arbitrary polygon, that's not that easy anymore. And for this, I came along I came along an article on Wikipedia, and I just coded that along. You don't need to understand that, really. You just, um, yeah, code that. What I'm going to show you. I mean, I'm going to code that too along, and you can just follow me. But it's basically a formula we're going to code now. And you can use, you can use that code really, every time if you need a centroid of a polygon, just use that. It's really awesome. It just works. And I'm gonna provide you a link to the article in Wikipedia too. Okay, so let's jump back to our project. Last time we created our shapes. I'm gonna just close that. And now I'm gonna create a new class, that's gonna be a math helper class, and I'm gonna add this into the utils folder. So just add math helper.js, and I'm gonna call this math helper 2. There we go. Then we have again two static methods. One I'm gonna call calc centroid, or calculate centroid, and for this we need to pass in the vertices. And then we have a function to calculate the area of a triangle part or of a section. This is also explained in the Wikipedia article. You also need to pass the vertices in there. And then, just for a helping hand, I'm going to introduce a new method. Okay, that's our third now. And I'm going to call this index. And this method will help us later to cycle through an array and to calculate things, like we did with the, I think it was shape. Yeah, right. A typical example is you can use this method in here, and then you don't need to write this line anymore because it cycles through or over the length of the array. And then if the index has technically more, or is a bigger number than the length of the array, it starts at 0 again, basically. And so it will never cause a index out of bounds exception, for example. And then we can technically move this one into that for loop, so we don't need to write a lot of code under the for loop anymore. But I mean, for this one, it's fine. But later on, especially at the collision detection section, we're gonna use that index method, because this is going to be a bit more, I mean, we're gonna save more lines with that. Okay, I'm just going to implement the index method. I'm also going to explain that later too when we're going to use it. So this is just index plus array size modulo the array size. There we go. And now to the more interesting methods. Calculate centroid and calculate area. We first need to calculate the area. This is basically, well, as it says, it's calculating the whole area of the polygon. And we do this. This is basically really typed or basically copied from this article. Yeah, just take a look. There are also some other posts on Stack Overflow which are explaining that too. Maybe I can show you what I'm gonna do now. Let me see. Yeah, there we go. I just need to change the window. The web browser. There we go. All right. First, so basically regular polygons, we want to calculate the centroid. There we go. This is it. And we are going to implement this method. And for this, we need to have that A first. And this A, we can calculate this. I think here, I think that is the right one. Just need to take a look again. Yeah, that's the right one. We're gonna implement this one first. This sum character, yeah, is just a loop over these positions. So we're just gonna loop over these positions with these indices. And then at the end, we're gonna divide it by 1/2. And then we have the area. And when we have the area, we can calculate the centroid, the position x of the centroid, or the x component of the centroid, and the y component of the centroid. Yeah, and that's what we're gonna do. So let's jump into code. Okay, calculate area. First, we're gonna have a variable a, and that's the point where we're gonna sum up the area in it. Then we have a length of the vertices. So I'm gonna save it in a separate variable. And then we're gonna loop through, oops, I don't wanna use the file reader. We're gonna loop through the vertices. I is equal to 0, smaller than length I plus plus. Okay. Okay, so now let's take a look again to the Wikipedia article. At the area, we see here we need to have an index. We need to use the y position or the y component of the index +1 and of the x component from the index position +1. And so we're gonna just add another variable. I'm gonna show you that. I'm gonna add a new variable. I'm gonna call it I next, for example. In this class, I'm gonna use I think snake case, it's called. but of course you can also use I next. Doesn't really matter. Yeah, and I'm gonna use the index method for this, because if you're not using that, we need to add everything what we're gonna write down under here again. And I don't want to do that. So I'm gonna use y plus 1, because we need the next index position. And we need the length of the array to get the next I. Okay, and then we are calculating A. So let's jump back to the browser again, just make sure everything is right. Okay, so we first gonna sum up everything. So we're looping through these positions. We're gonna multiply the x component with the y component at the index plus 1 and subtract this with the x component from the index y. Maybe I can make that a bit bigger. Oh, not that. Oh, where is it? There you go. And we're going to subtract that with the x component from the index position plus 1 times the y component at the index position I. Okay. It's a bit it's a bit complicated, but I think it's doable. Okay, so let's jump back. There we go. Okay, so we're gonna add to the area the vertices at position I with the x component, multiply that with vertices of I next, so of the next index position of the epsilon component, of the y component, sorry, minus the vertices at the I next dot x, and this times the vertices I dot y. And that's it, basically. Now we implemented that formula on the Wikipedia article. I'm just gonna make sure that everything's right. Just 1 second. Okay, we have the x position of this one times the y component of the next one, that's right, minus the x of the next one times the y of the current one. Okay, yeah, that's right, cool. Okay, and then at the last step for calculating the area, we need to divide the area by 2. And we can just say return A divided by 2. And that's it. Okay, cool. We implemented the calculating area part. And now we are calculating the actual centroid. Good. Let's go back to the Wikipedia article. The centroid, where was it? There it is. Okay. As you see, these both formulas are quite the same. They're iterating through the same indices. I mean, through the same range. So we can use the same for loop basically, and we need, yeah, we need to do similar things. So first we need to add the x position with the x next. Then yeah, we need to sum up this one. Then we need to calculate the other part first. So this x component with the y component for the next index minus the x for the next one and the y component of the current one. And when we have both calculated, we can multiply that and then sum up these values with the length of the vertices -1. Okay. Yeah, that sounds good. I guess we can implement it now. So let's jump back to the code. And there we go, calculate centroid. So first, I'm gonna save the area. So A is this dot calculate area from vertices. Then I'm gonna save the length again, because we're gonna make use of the index method we used earlier. And then I'm gonna save the CX, basically the positions, and set it to 0 first to sum it up later. And then we can cycle through everything. So again, a for loop. There we go. All right, since we have the index method, that's not that big of a problem. So we're just gonna use the iNext again with this dot index, and that's again I+1 and the length again, and then we can sum up the centroid x component. And as I said, I think I'm gonna calculate these parts separate from another. So I mean, I'm gonna sum up this part, then I'm gonna sum up this part, save this part and this part in separate variables, and then multiply both of them. It might be easier, but of course you can just write it down like it's in the formula. Okay, then I'm gonna say how I'm gonna call this variable. I just call it first. Yeah. First, and this is going to be the vertices of y, the x position, plus the vertices the I next from the x component, and the other term, or let's say first term and second term. And the second term is vertices. Do I need to? No, we don't need to embrace that with curved brackets. Okay, so okay, as a vertices 1.x times vertices I next dot y, and then minus vertices I next x times vertices the y component. Okay, and then we can say first term times second term and add that. So let's check that again, if that's right. Okay, so the first one is looking good. Yeah, that's correct. And then the second one is also looking fine. Yeah, okay, that looks nice. And now we can do the exact same thing for the y of the centroid. So we need to, oh sorry for switching. We can actually copy that and paste it in. And I'm gonna call that first term of cx and first term of cx, second term of cx. There we go. Yeah. Okay, and I'm gonna call this one first term of cy and first term of second term of cy. Okay, then just correct that one. Okay, now we need to check if that's right. Just take a look again to the formula. This part stays the same, but the second part is different, and the second part has just the y components in it. So that's a pretty easy fix. We just need to change that x to a y and that x also to a y, and now we have the set x and the set y position. But unfortunately we're not finished, because we need to still divide these positions. I'm just gonna show you what I need to do. There we go. This term. So we need to divide what we summed up by 6 times the area. And then we are finished with that. So let's jump back. At least it's quite simple. So we call cx again, divide by 6 times a, and the same thing for cy, 6 times a. Oops, there we go. And now we can return centroid. Oh, not the vertices, the centroid, new vector 2. It's gonna be cx and cy. There we go. Now we finished that. Now we can try if that's working. Just go to let's say to the shape, and we can draw a point there. Well, actually, I'm gonna go to the polygon, or to the rectangle part. Yeah, I'm gonna add the draw method to the polygon too, called super draw. And here I'm gonna calculate the centroid. And the centroid is math helper centroid. Of course, calc centroid. And I'm gonna pass this to vertices. And of course, we need to add that new method to the main HTML file. So just add this one, utils and math helper. There we go. And now just draw that with draw utils class. How did that work? Draw utils. Okay. Yeah, there we go. Draw utils. Draw point. Draw point at the centroid position with a radius, let's say 10, and a color of red. So I guess when I'm gonna start that now, it's not gonna work because probably I forgot something. But let's see. Let's switch to the browser, and there we go. I forgot something. Super keyword, unexpected there. Okay. Let's go to the rectangle. How I did this there. Draw. Okay, probably. Okay, I called that wrong. I think I called that in the Kotlin programming thing. So I need to call this like this and not like this. Okay, so just paste it like this, and now go back to the browser, and there we go. We have our centroids. Awesome. Yeah, I'm gonna change now this vertex here. I'm gonna change this vertex just to make sure that this centroid is actually moving. Okay. So it's a quite easy fix. Not a fix, but a change. This is the second one, second vertex, and I'm gonna move that by 200 pixels to the right. And yeah, and so what I changed here, I changed this 600 to 800. Okay. So now when I refresh, the red point should be moving, and it does. Awesome. Okay, now we implemented the calculating centroid part. Yeah, I hope it was understandable a little bit. And yeah, I hope you learned something too, maybe to interpret, for example, the formula, especially the sum. But yeah, that's it for this episode. Thank you very much for watching, and I hope I see you in the next one. Bye bye, and have a nice day.